looking at vectors. Now, let me get over here. If I pull on this string, coming off on this side, which way is this object going to go?
That's when I'm always getting it backwards.
Oh, you didn't. Depends on the angle of the string. Up here, see, it goes that way. Because where does this string trajectory touch the floor? Relative to where those two discs are touching the floor. If it touches on this side of where the disc is touching, you see it's going to come this way. I'm sorry, that's the wrong way. It's touching on the back side. It's touching on this side, it's going to go that way. Or if I get just right, slide, not roll at all. If the angle of this string touches the floor, right where the wheels touch the floor, then it slides, you see. Well, this gets kind of interesting then also in how you look at how you do work on cars and how where the wrench is actually lined up and so forth. I almost witnessed a serious accident and a kid changing a tire on the car. We were balancing the tires. One that you left the tire on the car and you had to make it and spin it up. Well, it got to pretty good speed, it was running about 20 miles an hour or something to that effect. So he decided he's going to stop the tire by putting his foot against it. Luckily enough, when his foot went up, it hit the fender and threw his foot away from the tire. Otherwise, it had torn his leg off. So motion can be dangerous, you see, in that sense. And so can the air pressure in those tires. One guy was airing up a big old truck tire that had a safety rim. I say safety rim, I was called a safety rim or not. You pushed the tire down and you had a groove on the rim that the ring had to fit into. It came off, cut the top of his head off. The other guy was laying on it, on another one, and it came off, and he said he was somewhere 6 or 7 feet in the air. It didn't hurt him too seriously. So pressure can do a tremendous amount of damage. I worked in a steel foundry where we were using a mixture of rosin and salt and sand and so forth to make the core inside of the frame of a train track or train body. And this rosin thing got choked up. We were blowing it through a 4-inch pipe with 100 pounds of pressure. So the way to clean the pipe was just to drop in a 6-foot log chain and blow it through there. And went over to the hopper, and you could go over and get it and start over and clean the pipe out. The young chap took the pipe undone on the hopper, hit it with pressure, and finally it broke loose. The pipe got to swinging. The 6-foot log chain went on out through the roof. So pressure can be rather serious. When you figure out, you're talking about the pressure on a square inch. Atmospheric pressure is 14.7 pounds. Pressure that you put in your tire, 35 pounds per square inch above the atmospheric pressure generally. So you're playing with some real dangerous stuff. Okay, what else is?
I saw earlier you had something that looked like it had a valve or a 90-degree air valve or something on there.
Oh, here's another one here though. This is before your time, or after your time, I guess, or before your time. Bernoulli effect is the idea of blowing air over a tube like we did over there, and you had a bowl of DDT. And so we always fed the cows with the mosquitoes in the house, the garden, porch.
Did y'all call it flit?
Call it what?
Flit.
No, I don't know that name.
They call that a flit gun.
Oh! That's interesting. It all works on air pressure, you see. And I thoroughly believe carrying one of these for several years may have well kept our family from having polio. And I still today believe that polio probably went along with the idea of having so many flies you couldn't hardly keep your mouth open during the day. And we had them on the farm. So, okay. Have I got something else? Oh. Here's one. I'll be able to show this one. Put those two marbles in the ends. do you want to go back over there and try that experiment again?
Hold on.
Hey, now you're getting onto it. Yeah, okay. Oh, I left this one out too, didn't I? I don't know whether I can make this one work or not. Not having any luck there today.
Is that rosin you're putting on your hand?
Yes, that's, see why you put rosin on the violin bow? To make the strings vibrate. It's so rusty, I don't know if it's going to work or not. Not too well there, but
Those are both solid?
yes. I have never tried it with an open tube, but I doubt that it would work. But you can set those kind of vibrations in just about anything. I mean, you even think about what New Madrid did up here in 1811. The vibrations that went through the earth. In fact, if you've driven Interstate 55 many times going on up into St. Louis, just the time you get to the other side of New Madrid and you start looking where you get the hills formed, look at those hills very, very close. You may not see it for the first half a dozen times, but pretty soon you're aware that hill really belonged over here. That hill really belonged over there, and they moved on top of the, now how deep it is, I don't know for sure, but you can tell that from the surface structures that those hills are not where they used to be. They moved them, they quite moved them. And, I don't have a Geiger counter either anymore.
You don't?
Here's a little bit of radioactivity. Away from me. Uranium trioxide. Now, uranium is radioactive. It throws out alpha particles. And it goes into another form of, it's not a periodic table there. But the idea being that the people had found that a lot of these chemicals in the earth made beautiful glazes, pottery and things of that nature. And this is a piece of fiesta ware. Have you eaten in a Mexican restaurant recently? Turn the plate over and see what it says on the bottom. Fiesta ware. Now wait a minute, you don't have to worry. Not every plate is radioactive. It's only if you still have a few of these around, and I don't think there's any of these left around anymore. I think they've removed them all. This is a beautiful glaze that's made with uranium trioxide. Now, when we finally found out this stuff was radioactive, and there's a lot of people in Tennessee and Kentucky where these things were made, coming in the household, and they found, radioactivity, it's dangerous, it causes a lot of problems. And so they crushed up all of their fiesta ware, took it out and dumped it in the backyard. It's still out there, it's radioactive. No, very little of it's radioactive. It's only this particular glaze, this orange glaze, that was radioactive. Now, actually, if I were to have this a cup of coffee, that'd be terrible. I don't like coffee. But if I drank a cup of tea every morning with this, or 3 cups a day, I wouldn't worry about the radioactivity of it. Now, if I started eating the cup, that's a different story, because the toxicity, the uranium gets into my body, then it's very dangerous to my system. And so, yes, I could have a poison from radiation that would kill me, but it wouldn't be the radioactivity. It would be the toxicity part of it. And so it's keep some of these things separate. This one's a little different story. We used these during the World War II to mark the shore, the border of the ship, so you could run without lights. But these things would glow a little bit at night, and you could walk around on the deck, knowing where you could walk without falling off and so forth. Then they found out they could put them on the back of the guy's collar that was going through the jungles, and you could follow the guy in front of you. Until somebody realized, boy, these things are hot. They are highly radioactive. So they took them away from all the military and put them on a surplus market for the civilians. That's how I got this one. I bought this one in Denver. I think I paid 35 cents for it.
Is that what they used to put on the luminous dials of watches?
Same idea, and it may not have been the same chemical because there they used radium and a few other things. And Emil Grubb was one of the guys who first found that this radiation might control breast cancer and so forth. And he had worked with this stuff so long. At the time of his death, he had had 95 surgeries to remove parts of his face and lost most of his both hands. But he was the one that really started to using radiation in treatment of breast cancer. And this story I do not know for sure. I'd like to find out. I looked on the internet and haven't found a story. The Shah of Iran, his wife had thyroid problem. And so there was no treatment over there, but Oak Ridge was just getting started in doing medical work. This was after World War II. And so he brought her over here to Oak Ridge, and they treated her with radioactive iodine, which is thyroid uptakes. And sure enough, they cured her problem of the radioactive, or the thyroid problem. And it's my understanding that's how the alliance was really set up between the Shah and the U.S. And of course, after he was kicked out or disposed of one way or another, well, then things fell apart. But pretty interesting story if it's true, you see. And Oak Ridge was one of the few places that they first started using, using serious efforts toward using radioactive material to control cancer. And the beds there, the hospital beds they had, you had to have the commitment of about 2 doctors, all the family relatives, and the person that was going to be sent to Oak Ridge, that they would realize that they were on their deathbed anyway. Let's go to Oak Ridge and see if there's anything we can do with radioactive material that might help save your life. So that's how Oak Ridge got so involved with radioactive material. And oddly enough, I carried radioactive material into the schools, very, very minute quantities of radioactive iodine and radioactive phosphorus. Well, the iodine would uptake for the thyroid gland. So I get an old rabbit and give him an injection and tell the students, well, we're going to watch and see where this goes. About Friday, we'll examine the rabbit and look at it to see. Sure enough, you hold the Geiger counter underneath the throat. It works. You see, we had injected him in the hip and the iodine went to the throat. One day, I had this old granddaddy rabbit. He was the biggest, oldest, and toughest rabbit I've ever worked with. And I guess I did not get that needle into him. Because I checked him on, I do that Monday in the auditorium where I have 1,500 kids watching me do it. Can't do that today. But watch me do it, and then I tell them, Friday we're going to find out. Tuesday, Wednesday, Thursday, no activity. Boy, I blew that one. But I had a little bit of radioactive phosphorus left. I spiked him. I put a little radioactive phosphorus up here on his neck, brought the Geiger counter up there. See, it works. But almost the same thing happened down here at Richmond Dome. Somebody found a 3-legged tadpole down there, and it showed iodine. And I went to a guy up here at the college. I said, look, I've worked with radioactive iodine, and if I remember right, the half-life is about 7 days. Long half-life. Now, that Richmond Dome was, 20 years ago, 30 years? Several 7 days in there. Do you expect to find a tadpole down there that's radioactive with iodine? The answer is no. Well, what's wrong? So the young chap up there in that other college, Ole Miss, decided that he had some dirty dishes. Yeah, he spiked it. I know. I just noticed this day that he probably spiked it, so he'd have a hot tadpole. Called up the governor, and I can't remember who that governor was at that time. Who drove the semi before he became governor? Can't remember his name. But he called up the National Guard and the police force here and the city force and the government force. Go down here to Richmond. Move everybody out, 2:30 a.m. Sunday morning. Forget it. We've been here for 15 years. So finally came through just as a fluke and somebody's wanting to get a good grade. So radioactive material, and I got to eat dinner in a place, the guy that did so much research in Utah and Arizona. He built his house way up on top of this hill. Had to have a force pump to get the water up there because he had a swimming pool. Well, he made and lost a fortune in hunting down uranium, or thorium really. That's what he was looking for. And so Gene and I had supper up there one night, so kind of interesting. Okay. You want to get into some math? No. You hate math. Oh, I wish I had my T-shirt. One says, I love, no. It says I. It didn't say I, it says square root of minus 1. What's the square root of minus 1? When you take the square root, what's the square root of 4? 16. Number multiplied by, no, that's the square of 4. Number multiplied by itself that gives you that value. Square root of 4 would have to be 2. 9 would be 3. 16 would be 4. What about a minus 1? 1 times 1 is still 1. Minus 1 times minus 1 is still pardon me, 1. I don't come up with a minus 1. It doesn't exist. It's imaginary. And so rather than type all that stuff out with a typewriter, which you couldn't back 40 years ago, we just decided to use I. I love math. Square root of minus 1. 2, 2, 2, 2.
We go to the class here, we talk about the letters for current and inductors and things like that, and a lot of letters get taken out of priority.
What's wrong over here?
We got power there. It's a jiggly outlet, so you may
Okay. Whoop. There we go. Okay. Well, I guess first question is, check you off for sure. You know what this number is? You failed. That's 1,023. See, I count a little bit differently. 1, 0, 1, 0. That's not too impressive, is it? How am I going to get my 2? Well, when you got up to 9, how did you get to 10? You moved over, didn't you? Okay, there's a 2. 2 plus 1 is 3, 4, and that's not an obscene number. You guys got to learn how to read. You turn your hand around, it's dangerous business, you see. This way it's okay. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And go through all this, and this is 32, 64, 128, 256, 512. 1,023. 1K. Ever heard of 1K? It's not 1,000. It's really 1024, 1023 if you don't count the 0. Okay, that's the same thing I'm going to do here, this little box. When I was at Oak Ridge, they started teaching us something about binary number system. Wow, that really fascinated me. So I went home in my wife's backyard, and her father was a carpenter, so I built me a little counting box. And this, LEDs did not exist. They weren't around. So this is a percolator top out of a coffee pot. And this back here, that filament transformer we were talking about, put out 6.3 volts, you see. And the rest of this is a part of under the dash of a Chevrolet car. You get 6-volt battery, 6-volt bulbs there. So there's my 1. Well, I'm out of numbers. Now I'll move over to 2. 2 plus 1 is 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. And I can't play the piano. Pardon?
Do you guys understand what number system he's talking? All right, let's go back. He had his pinky up and down, and he was saying 0 and 1. How many digits do you have? You got this digit and that one. What's the total number of digits? 2. That's a 0 and that's the 1.
Because zero is a good digit.
Yeah.
In other words, I'd like to get one of these checks that says 1, 0, 0, 0, 0. Those zeros are good digits.
All right, try this. You had your choices of answers are true or false. How many choices did I give you? True or false? How many choices did I give you? 2.
Left or right?
You see the 2 there? It's a base 2 number system.
Yeah.
2 available digits.
And the interesting thing is, you see, that binary system,
What does bi mean? 2.
a bicycle, yeah, okay, 2 wheels, yeah, okay. But you have yes and no, left or right, up or down, stop or go. Boy, we got a lot of stuff. Yes, mother, no mother. You know, a lot of stuff that we answered with those 2 symbols, those 2 choices. So Boole was a young chap, about 13 years of age, and he was teaching school, and he thought that he could come up with this number system that would really basically answer all the questions that you might have in science or something, this binary number system. Well, by the time he was 13, he owned a school, and developed some of this binary number system, counting system like that, adding system. I can add 2 plus 2 and get 4. See, there's 2, and add another one, moves over 1. Oh, look, 4 plus 2 is 8. 8 plus 2 is 16. Every time I multiply by 2, I just shift over, don't I? Register shift in a computer? Ever heard of that? Well, you probably don't. You work at that low level. But this one chap in telling my story now. I went to Texas A&M. In fact, I got my PhD at Texas A&M, and the guy asked me, yeah, where did you get your education? So you're an Aggie, but where did you get your education? Rubbing it in. I had I had about 4 good teachers. 2 lousy ones, but 4 good teachers at A&M. But okay, I had this class by a guy who actually developed part of the old assembly level language back on the early days of IBM and so forth. Brilliant teacher. He was talking about the register shift. And this one graduate student says, you mean to tell me that those numbers are in that computer and it shifts over? No, just push the button. And the sequence shifts over in the register, you see. You multiply by 2 very, very easily. Okay, now the next question is, I can come up with a pretty good counting system and a binary number. And this one is a little bit bad because I have only, 6 lights up there? I really ought to have had 8 because most of your systems today use 8 places. Why did that come about? See, the old signal system was flag up, flag down, flag left, flag right, and you had 2 choices there, essentially. But then we began to improve on this to come up with better number systems. Morse code came in there somewhere. I think had 5 lights really for Morse code. How many symbols? You had to leave out the Q, something like that. But how many things can I do with that? I can add, I can multiply, I can subtract, and multiply to shift, you see, and divide to shift the other way. But supposedly I want to do codes. Quit playing with numbers. Let's play with A, B, C, D, E, F, and G, and so forth. Well, if you build a system like somebody was playing with over here the other day, where I take the 8 bits, 1, 2, 3, 4, 5, 6, 7 bits. Why did I use 7? 4 times 4 is 16. Now I can get up to um, 32, 64, I get up to 128 there. Let's see, how many bits would I need to represent all the numbers you need to know? Well, only 10, 0 through 9. You can just move over for another column if you want to do that. But then if you want to represent A, B, C, how many alphabetical characters do we have?
You got uppercase and lowercase.
26, isn't it? That's 52, right? You need a comma, a period, question mark, slash. Roll the paper up one step. So seven bits will give you what? 8 comes up to be, what we got here? 32, 64, let's see, 16, 32, 64, 128. So if I get 8 bits, it'll give me more than I need. 7 bits will actually do it. 7 bits. So I only need 7. Well, if I want to talk about the alphabet, if I break this 7 bits into 2 phases, one over here and one over here, then with these numbers on this side, I can actually go to a hexadecimal counting system, because if I had all these on, there's 3 and 4 makes 7, and 8 makes 15. If I want to use all those as counting numbers, I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Use all of those as digits. And that's the way we send messages up to the shuttle. Who would want to send messages up there on any other system? Hey, that takes care of 8, well, we actually have 4 bits there, and you can go up to 16 total digits. Then if I turn on one of these, I can play codes. And so that might be A or B, and I have my paper here. So I can use these 3 over here to represent part of it, turn that one off and turn this one on. And this would be a different alphabetical character. So I can represent all of them with the same thing that I was playing with over there in binary. Now, actually, 8 bits is something that's normally used, because it turned out that they made a 4-bit package. Duplicate that and you had 8 bits, you see. So that's one of the reasons we went to 8 bits. But is that a byte? 8 bits is a byte? Anybody learn that? I hope you didn't, because it ain't true. The word byte is generally a manufacturer's name for how many bits he wants to ship along on a cable at one clock signal. One company shipped out 54 bits. And 54 cables coming out of click the clock, and 54 bits went out. Well, that's what they apparently needed. Another one had 12. Pace, I think it was, had 12 bits. And so the word byte is not truly defined, except somebody wrote a textbook and said, we'll call 8 bits a byte. No. Everybody pretty well uses that, but it's not down in stone, because really that's a manufacturer's term. How many bits he wants to ship on the line at one time. Okay, so when you send messages up to the shuttle, it's like that. Use 8 bits at a time, really. Now, with 8 bits on there, you can even get into graphics. So, kind of interesting way to send information, you see. Oh, here's one. Air pressure experiment. Let me blow the ping pong ball out of the phone. And I'm blowing. Jumps up in there. No, doing what? I'm blowing like this? No, I'm blowing through the stem. Bernoulli effect. The idea of air coming over out of the funnel, coming over the top of the ping pong ball reduces the air pressure there, and it's the air pressure around my fingers here that pushes that ball up in there. And so, air pressure is kind of interesting. Oh, I left out a beautiful experiment in a series of bottles. I think it's over here. Nope. What have I got in there? Yeah, maybe it's that bottle. Yeah. Well, have I lost that experiment? Maybe so. Got another one to show you though. Slinky. Where can I run a slinky? On the floor?
Steps or board, incline,
Or not inclined, just flat.
floor, I guess.
Let's try it down on the floor. You've been on the floor a few times this morning. You want to try it again? Let's see. You hold the little one. And I'll try holding the big one here. Let's get down on the floor. My old knee's going to do this. I guess so. Now you compress a little of your spring, something like this. Send me a message. You hold it. It'll take two hands to do it. Hold it down on the floor. Now compress up a bunch of the spring. Oh, do that one more time. Did you see a reflection at the interface? Kind of quick to try it again. Oh yeah, because the density is different, and so we get a reflection coming back off of the interface between these two objects. I get a reflection coming back from my hand up here, but right there at the interface you also get a reflection. Oh, sonar works that way. If you send a beep out of a sub and you hit cold water, you'll get a reflection. If you hit another ship or a rock, you're going to get a reflection. And with parts of, okay, I'm up here again, artificial knees. With the recent work on the submarine, they've been going all over the ocean where they find mountains or hills or new volcanoes being formed. They've been painting it and so forth and get some idea of what the size of it is, but then immediately get the hold of GPS, so we have it plotted. We know something about doing warfare and things like that now much better. Had my brother's son-in-law was on a sub, atomic sub, and they left North Pacific Ocean, and in 5 days docked at Norfolk, Virginia. 5 days going around the Horn. So they were moving, but also and never surfaced. 5 days. Okay, mine said the same time. What should we do now?
We're gonna wrap up. So
Okay. Well, I've had a lot of fun teaching, kind of getting a little, I guess, slow at it now, 80 years old and slowing down a little bit. But it's been fascinating.
What kind of car you drive? That's what they want to know.
Well, that's kind of my wife's car. Kind of came time to change cars. We had a nice Buick, a small Buick, a Sabre, beautiful car to drive. And so she decided, let's get this. And so by pension budgets and also taking some out of savings, we bought the Cad. The worst driving vehicle I've ever had under me. And I drove a Model T Ford when I was 7 years old. And it had terrible steering problem because that's all the steering had was a quarter turn each way with the wheel. But this thing, and we came up with some illness in the family, so we had to make 2 trips to Melbourne, Florida. And then I had my twin sister decided that she wanted her birthday early, so we had to go out to Dallas to that. Got back, I had a tire just about worn out. Good heavens, why did I think of this in the ahead of time? I've worked on cars enough to know that when the wheel's out of line, they don't drive right. And every wheel on that CAD was out of alignment. All 4 of them were out of alignment. Well, we got it aligned, put another set of tires on it. Hey, it drives pretty neat. Drives pretty neat. But, you know, just to go out and buy a CAD, I wouldn't buy a CAD. I think they're a pretty well-made car. Hell to get into. Scratch that. At least when you got 2 brand new knees, artificial knees. And that's a new little idea too, because I got where I couldn't climb a ladder. I had to pull myself up a ladder and doing some work up at St. Thomas there. I decided, hey, it's time to go get your knees fixed. So I can get down on them, particularly if I have a set of knee pads that get down pretty easy. But hey, there's a great, great thing. There's a lot of people that have had their knees worked on. You must do the therapy or it ain't worth it. You must do the therapy and probably continue the therapy or a certain amount of it the rest of your life. But that's great. I'd do it again if I had to.
Let's give a round of applause, folks.
Did you guys play with my puzzles?